Welcome back to the second section of Chapter 6, which is about angles and polygons. So, I know a lot of you have now either gotten your permit or your driver's license or are about to get it in the next few weeks. Now, when you get your driver's license, it might be the first time in a while where you're away from home and you're all by yourself. What else? What better to do than to do this? Well, I know I love singing in the car or lip syncing in the car because you don't want to hear me sing. I don't want to hear me sing. There's one thing that you should do. You should do this instead.
I gotta pull over. Yup. Hello, it's me.
So I certainly want you guys to pull over if for whatever reason the music is just so good and you need to stop. The reason why I started off with or ended with Adele was because in Adele's song it talks about hello from the other side. And today the exterior angles are going to be saying the same thing from the other side. So today our objectives are to determine the sum of the interior angles, determine the number of sides of a polygon, and to identify exterior angles and determine the sum of the exterior angles. So we're looking at interior angles and exterior angles today of polygons. Okay, so we have all of these polygons right here: triangle, quadrilateral, pentagon, hexagon, and n-gon. So n-gon is like any kind of polygon that has any number of sides. So triangles have 3 sides, and within a triangle there is only one triangle, and the sum of the interior angles of a triangle is 180 degrees. This was something that we learned back in Unit 4, maybe 5, Unit 5. Now quadrilaterals. Oops. So quadrilaterals, if we just take a look at one vertex and make all the diagonals we can from that one vertex, we can create one more diagonal. And therefore there are 2 triangles in a quadrilateral. And it turns out, so the reason why I do this is so that all these triangles, these 2 triangles, make up the angle measures in the actual polygon. So you can see that if we add up the angle measures in this triangle and the angle measures in this triangle, we get that angle. And so if we add up the angle measures in this triangle and that triangle, we should get the angle measures of the quadrilateral. So 2 times 180 gets us 360. If we do the same process for pentagons, which have 5 sides, it will have 3 triangles because we start from one vertex. It can be any vertex, but then we choose all the diagonals we can from that one vertex, and there's 2 more diagonals, and it creates 3 triangles. And the 3 triangles create all of the interior angles of this pentagon. So there's 3 triangles, so therefore the sum of the interior angles of a pentagon is 540, or 3 times 540. Now, try to see how many triangles would a hexagon have? Well, it would have 4 triangles because there are 3 diagonals that you can make from a certain vertex, making 4 triangles. And therefore the sum of the interior angles would be 720, or 4 times 180. Lastly, we have n-gon, so any number of sides. So what's the relationship between the number of sides and the number of triangles? Well, it's that there are always 2 less. If this is 3, 3 minus 2 is 1. 4 minus 2 is 2. 5 minus 2 is 3. 6 minus 2 is 4. So the number of triangles of an n-gon would be n minus 2. Now, what's the relationship between the number of triangles and the sum of the interior angles? Well, we have the sum of the interior angles is the number of triangles times 180. So for this, it would be the number of triangles times 180 degrees. So n minus 2 times 180. This is the sum of the interior angles of a triangle. So again, just in a sentence now, the sum of the interior angle measures of a convex polygon with n sides is n minus 2 times 180. So this rule only applies to convex polygons. There isn't really a rule for concave polygons. Yeah, so convex polygons, this is the rule. So let's take a look at a few of these problems. Find the sum of the interior angle measures of a convex heptagon. So how many sides does a heptagon have? It has 7 sides. So we would have our n minus 2 times 180, n representing the number of sides of that polygon. So if n is 7 for this heptagon, we would say 7 minus 2 times 180. And 7 minus 2, and it's really important that we have those parentheses because we don't want to mess it up. We want to make sure our order of operations is correct. So we do 7 minus 2, which is 5, and 5 times 180 equals 90 degrees, 900 degrees. So the sum of all the angles of a heptagon, no matter, as long as it's a convex heptagon, would be 900 degrees. Now find the measures of each interior angle of a regular 16gon. So what does it mean if a polygon is regular? Well, it means that all of the angle measures and all of the side lengths are the same, are equal. So that means if we can find how many degrees, what's the sum of it, we can also, and we know how many angles there are, we can divide the sum of the interior angles by the number of sides. So I'm going to first find the sum of the interior angles of a 16gon or a 16-sided polygon. So n in this case would be 16. So it would be 16 minus 2, 14, times 180, which is 2,520. Now, but I want to find each angle. And in a 16gon, there are 16 angles. And in a regular 16gon, there are 16 congruent angles. So all I have to do is divide by 16. So 2,520 divided by 16, and I get the wonderfully rounded number of 157.5 degrees. So each interior angle of a regular 16gon would have 157.5 degrees. Now, we're moving on to a new thing. So below are 3 regular polygons. Find the measure of each interior angle. So this is like an equilateral. It's a regular triangle. What's the measure of all 3 angles? What's the measure of all 4 angles of a triangle? And what's the measure of all 6 angles of a regular hexagon? Now, find the measure of each exterior angle, then find the sum of the exterior angles. So now, using the numbers that you did to find the angles, the exterior angle is always a linear pair to the interior angle. So if this is 60 degrees, the exterior angle would be 120 degrees. So for the triangle, the sum of the exterior angles would be 120 plus 120 plus 120. Now do the same for the square and the regular hexagon. For the square, you should get 90, 90, 90, 90. And the hexagon, you should get 60, 60, 60, 60, 60, 60. 6 60s. And it turns out all of these add up to 360 degrees. But this is not just the case for regular polygons. It can also happen for irregular ones as well. but they have to be convex polygons. So everything that we're learning in this section and really from here on out are about convex polygons. So in the polygons below, an exterior angle has been measured at each vertex. Notice that in each case, the sum of the exterior angle measures is 360 degrees. So it works for all convex polygons that the sum of the exterior angles is 360 degrees. No matter if it's a triangle or a 100-gon, the measures of the exterior angles will always add up to 360 degrees. So let's do some problems. Find the measure of each exterior angle of a regular 20-gon. Okay, so we know that the sum of the exterior angles equals 360 degrees. And we know that since it's regular, all of the exterior angles are going to be congruent to each other. So what we can do is that we can do 360 divided by 20, and we get 18 degrees. So each exterior angle is 18 degrees. And I believe that is it. So please go on to my website and do the 6.2 online quiz. Thanks, guys, and have a good one. Stay safe out there. Keep your eyes on the road. Bye-bye.